In partnership with the Department of Trade and Industry, a fabrication laboratory or Fab Lab in Bohol was established in May 2014 as part of a global network of local fabrication laboratories that nurture ideas. A space for co-creating, innovating, learning, and sharing knowledge. To foster local economic growth and community advancement through creative solutions, DTI, through Fab Lab, has identified 4 areas of development: innovation, MSME assistance, capacity development, and collaboration and partnership.
A Fab Lab is an interdisciplinary space that promotes innovation through the use of digital fabrication tools. It's a modern facility that allows our SMEs to do prototyping. For the last 1.5 years, we have been teaching them digital fabrication skills, which are very much in demand in the world market.
For us, it really would support creation of maybe high-end products and development of new enterprises that are technology-based.
This one will be the common service facility of industrial designing in the province of Bohol. There are even seminars, conferences, workshops conducted here so that Fab Lab enthusiasts and other designers would use the facility.
The concept was introduced to us by our Japanese volunteer, Mr. Yutaka Tokushima. He noticed in the course of his product development activities here, he noticed that a lot of the problems in prototyping could be solved if we had the right equipment to do it.
We've catered SMEs to really expand their market into the tourism sector.
We have all these industries, and ang thing is they're all kalat-kalat and they're all spread out, and I think having this Fab Lab would bring them all together.
True to its thrust in catalyzing innovation, DTI, through Fab Lab and its local partners, has initiated key programs, projects, and unique initiatives in the areas of waste upcycling and material engineering. Prefabricated shelter designs, startup support and development, equipment development, and knowledge hubs for new innovations and technology-based solutions.
The timing man nga ning abot ang tagahapon nga mo naa sila ihatag. So mao to nga nalipay may kay ni aning abot ning kiwi house nga mo gi karon na mo serve as daycare center.
Key MSME assistance initiatives such as product design, product development, productivity enhancement, and marketing solutions have been significant drivers in the improvement of grassroots entrepreneurs and homegrown innovators.
We do some native bags, placemats, wallets, curtains, and lately I do trophies and medals for the triathlon with the use of Fab Lab facilities.
The problem that artisans face here in Bohol are really the same challenges that any small business faces across the world, and that's how to get your product in front of your customer. So we developed a kiosk called the Made in Bohol kiosk and sought to have it located in the luxury hotels where the tourists were staying.
Pag butang nimo aning dating molder na mo, pag butang nimo, patigasin pa. In pila ka minuto pa usa pa nimo tanggal. Broken ni siya, gasigi pamighimo ana, kasi mo iwa pa mahuman ng uban, pwede na mo siya hitakta kay gahi na. Wala na kay minuto o oras nga magamit aron pa mugahi aron maputos. Kani siya diretso na. Mas daghan, mas napasayon, mas niangay ang among customer. So dako kay natabang ang Fab Lab sa mua.
Ang improve na siya nga sticker namo sa bagol na siya kay ang among canister is naka-embed man siya sa taklob. So kani siya sa bagol na siya. Kay before mag-cut out man ni kami mag-print, ordinary lang nga bond paper ang gigamit, kami na sa mag-cut. So karon nga na-adiri introduce siya sa DTI. So naging try ko nga magpa-print. Ganahan na sila. Sila ay nindot lagi mag-packaging. O kuan lagi ni klaro kaayo, o sinaw na lagi ni. Kanang nga na siya na mga feedback ngayon ana.
When Fab Lab came, we had this partnership with them para maging competitive din tayo sa market. So, eto po yung isa sa mga naitulong ng FabLab. This is our newest package na po sa mga placemats po namin. Madami po kaming nabenta na po nito, and we're very thankful to FabLab. Tumaas po yung income ng kooperatiba. Kasi may added value po yung mga produkto na namin.
To fuel global industry competitiveness, local entrepreneurs, students, and innovators are brought together to equip them with 21st century skills and tools through digital fabrication, technology trainings, and livelihood trainings and seminars.
It's for everyone. I would say a lot of people really likes to make almost anything. Doon, merong bata, merong matanda, merong zero knowledge, merong may medyo alam na. When you see people came in and then yung parang may sparkly eyes sila dito, when they came like, oh, pwede pala to siya, pwede palang gumawa ng ganito.
The Department of Trade and Industry conduct workshops and trainings for those because they want also to help those young local people here in the country. Because they want also to enhance their skills, improve their skills by the use of the FabLab Bohol. So, because FabLab Bohol, the concept of FabLab Bohol is to innovate and to create inventions by the use of digital fabrication.
This FabLab should be duplicated in other regions because this is a good avenue for developing the skills of designing on the students' part so that we could be ready or we could be at par with other countries in designing.
It's actually, for me, it's like a gold mine. A gold mine for innovators. Because everything are there na. Laser cutter, the shop boot, 3D printers, Arduinos, mga testers, na ito. As of now, there are so many micro and kitchen-based enterprises that would really need to improve or upgrade their technologies, their equipment. And that's why we are supporting FabLab because it is our vision that this facility could help those in making those customized equipment.
The FabLab affords its users access to global knowledge through regular educational tours and access to the international FabLab network. Local and other Philippine startup communities, enterprises, designers, and enthusiasts are encouraged to collaborate amongst themselves to expand and strengthen their niche in various market networks.
ボホールではファブラボを使って、必要なものを必要な分だけ作るというイノベーションが徐々に現地の人の手を使って生まれてきています。これは、他の国のファブラボでは見られないようなボホール独自のイノベーションと言えるようなものです。
The laboratory boasts of an array of digital fabrication equipment which include a laser cutter, 3D printers, a digital embroidery machine, a print and cut machine, a CNC milling machine, and an automated wood milling machine. FabLab Bohol also houses a pool of passionate in-house designers and highly skilled staff who can assist in 2D and 3D design, skills training, modeling, and production.
Our task here is to assist those researchers, innovators. So what we did here is not for us to create their idea, but them to create by themselves, and we will assist.
In partnership with the DTI, Bohol Island State University, DOST, and the Japan International Cooperation Agency, or JICA, and the local community of enterprises, FabLab stands at the center of innovation in Bohol.
We are very thankful of the help of the DTI. They can give you a very good service and you really can come up with a very good product.
Kasi we want to be Gandum Weavers to really soar high. And our partnership with FabLab will bring us to that level. So thank you po, FabLab and DTI.
I encourage everyone, especially taga Bohol, mga students, mga innovators, or mga out-of-school youths
try mo sa FabLab. If ever wala pa niyo nakita ang imuhang gusto himuon, no? Basin naanan mo kita sa FabLab.
It's a great privilege to sa ato kay na natagan tag chance nga matagan ng FabLab diri niya. Makita mo, ma-amaze dito sa mga magama ning FabLab, matabang niya para nato sa Bohol.
If you wanted to build a robot or night vision goggles or just something that lights in the dark, this is the place for you.
I would like to invite everyone to come at FabLab and let's play with these machines and let's work that idea out.
きっと皆さんのアイデアと、ボホールが持っているイノベーションがそのコラボレーションすることによってさらにもっと面白いものになると思います。ぜひ皆さんボホールにお越しください。
FabLab Bohol, a place where ideas turn into reality. Ideas that can improve lives, not just for Boholanos, but for all Filipinos.
Mga kababayan, ang pambansang awit ng Pilipinas. Kayang mag-ibig, teras ng sinakanan, alam ng puso, sa titik mo'y buhay. Upang hinirang, kuya ka ng mag-ibig, sa manlulupin, di ka pasisigil, sa nagatang tulong sa simoy at sa langit mo bagaw, ay hinatang tulak, awit sa paglayang minamahal. Ang isang ng matawad mo'y tagumpay na nagkinitig, ang bituin na araw niya kailan pa may magdidinig. Lumang ang araw ng walang pagsikta, buhay langit sa piling mo. Ang ibigaya na pagkay mga amin, ang mamatay ng dahil sa'yo.
Hi, hello, good afternoon, everyone. I hope everyone can hear me clearly and that I'm visible on my camera. So first off, my name is Mona Alcudia. I am the manager of FabLab UP Cebu, and I will also be your host for this afternoon's activity. So once again, good afternoon and welcome to the first of many webinars we'll be having this month that are brought to you by the Department of Trade and Industry, or DTI, in partnership with the Department of Science and Technology's Advanced Manufacturing Center, or AMCEN for short, where we will eventually be leading up to FabFest 4 on November 24 to 27 with the theme Fabricating the New Normal. So FabFest 4 will have a series of webinars leading up to the festival that will feature local and international experts like we have this afternoon, who will discuss various topics on innovation and design. So this event will be brought to you live, say hello everyone to the cameras, via Zoom and Facebook, starting this afternoon, November 4, 2020. So all these webinars that will be starting from this afternoon up to the end of November are expected to gather a wide range of FabLab enthusiasts, the general maker community, students, faculty, and stakeholders of the innovation sector in the Philippines. So I hope everyone is looking forward not to just this afternoon's webinar, but for the rest of the exciting activities planned for this month. So to give us an overview of this afternoon's webinar entitled Clay 3D Printing for Human Needs, How's art and culture, digital fabrication, and food, let me call upon the Senior Science Research Specialist from AMCEN, Engineer Leaf Colorado. Engineer Colorado, can you please turn on your camera?
Hello everyone, welcome to FabFest 4. I am Leaf Coronado from DOST MIRDC AMCEN. The wide range of WASP 3D printers has been developed to answer human needs: food, housing, health, energy, work, art, and culture. Joining us today are one of our experts in 3D printing of clay material. From a revolutionary company, WASP, please welcome Mr. Neri. He has been working for over a decade on the development of products in the international network of Technogym and is connected now with WASP to create an international commercial network. Again, please welcome Mr. David Neri.
Hello everyone, good afternoon. For me here is morning. It's a winter morning, very dark and cold. Thank you for inviting WASP at FabFest 2020, and thank you to the whole organization that allowed us this opportunity to share with you what WASP does and where WASP is going and moving forward. Thank you also to the maker community, because WASP actually started in 2012, and our first appearance in a public event was during the first edition of the European Maker Fair that was and is still in Rome in 2013. So we are very grateful to the maker community because we started our journey exactly as makers. Then we developed the company, the organization, becoming an enterprise. Now I'm presenting you and telling about WASP and about the technologies that we are embracing, including also the fluid dense material technology that we have called liquid deposition modeling, LDM. I'm going to share the screen with you. Okay, can you see my screen? Okay, so WASP is a small enterprise, an Italian small enterprise that produces 3D printer to answer the human needs and to help a transformative approach to industrial production. We also played with the acronym World's Advanced Saving Project. So we are joking among ourselves because when we are busy, we are used to say, no, sorry, I'm not available. I'm saving the world. We can face nowadays a lot of challenges. Among them, the density of population, the health issues that are facing today due to the pandemic, the planet that is really in a risky situation. We see that there is the red areas are where most of the population is living. So you see that there are some parts on the planet that are almost white because they are not populated, and some others are very, very, very highly populated. At the same time, we are also trying to 3D print lunar village. So we are also looking at somewhere else instead of being focused on our planet. WASP took inspiration by nature. Observing nature, Mr. Massimo Moretti, WASP founder, saw that in nature there was someone that could exactly represent a very efficient and sustainable business model, and it's the potter wasp, because this little white and black insect can take the soil nearby, can mix it with salive, and then the potter wasp is depositing as a 3D printer does, creating its very hard house, its nest. So the vision of Massimo Moretti was, what if we could scale up a 3D printer in order to 3D print houses, sustainable houses, and this was the starting step from which WASP started its journey. This is already an obsolete picture of the team, because the company, despite the economic crisis, the health pandemic situation, is still growing. So we are even bigger now compared to 2 years ago. And the team, a very motivated team, is very, very important, together with a very strong commitment, because our motto is we are not so crazy to think we can save the world, but we are crazy enough to work for it. So exactly, it means that what we do every day, every activity that we do is aiming to give a positive impact to the world, to leave the world a better place for those who come next to us. It's a very challenging statement. It's a very challenging commitment, but it's exactly what is leading us to do what we do every day on our daily activities. This is our business model that is really very, very simple, because as I already said, we want to answer the basic human needs. In fact, if you look at the 6 main areas in which we research, you can see that this is our business model that is really very, very simple, because as I already said, we want to answer the basic human needs. In fact, if you look at the 6 main areas in which we research, you can see that this is our business model that is really very, very simple, because as I already said, we want to answer the basic human needs. In fact, if you look at the 6 main areas in which we research, you can see that this is our business model that is really very, very simple, because as I already said, we want to answer the basic human needs. In fact, if you look at the 6 main areas in which we research, you can see that this is our business model that is really very, very simple, because as I already said, we want to answer the basic human needs. In fact, if you look at the 6 main areas in which we research, you can see that this is our business model that is very, very, very sad because as is already said, we want to answer if you the basic human needs. In fact, if you look at the six main areas in the field of research, you can see that this is our misunderstanding. Medium size and big size 3D printers for different applications, and the revenues that we can get are exactly reinvested in order to keep our business model spinning. It's a bottom-up business model because it's starting from the basic needs of everyone. This is the layout of our plant, of our headquarters. Again, it's an obsolete picture because it's different. For instance, the area, the green area at the right side that we call Shambhala is much more populated now. This is again an image, a picture that is dated 2018, 2 years ago. And now the Shambhala area is much more crowded. There are much more structures, printers, stuff there, because Shambhala is for us the experimental field, the playground, where we try to make the WASP, the company vision, tangible, where we make experimentations. And in fact, you can see here in the middle the big Delta WASP, that is the tallest 3D printer in the world, that is 12 meters tall with a diameter of 3D printer for houses, to print houses. And it was born in 2015. We tested it, we printed with natural materials using local sourced mud, raw earth, and natural fibers, straw, for instance. We 3D printed a huge architectural shape in order to test the machine, the software, but at the same time also to test and check and understand the behaviors of raw earth 3D printed, because there is no history about 3D printing raw earth. There is a huge heritage and huge history in terms of raw earth in Adobe, but not 3D printed raw earth. And then from that time, we understood a lot of things. We understood that this printer was not efficient at all. So we moved to a second generation of our Delta printers for construction. Then afterwards, we understood again, we learned a lot of other things, and then we moved to a third generation, and I will present it later. Then here you see that there are some other structures. Here is Gaia, that is the very first 3D printed house made with local source, the raw earth that was coming from here, from this area behind Gaia, and the rice waste. So the waste coming from the food and agriculture chain, local sourced, because I didn't know, but Italy is the biggest producer of rice in Europe. So there is a lot of waste, and the waste coming from rice has to be disposed, and you pay to dispose it. So we thought, what if we were able to transform the rice waste into a resource, a useful, valuable resource to make something else? And in this case, we used raw earth coming from here and waste from rice, straw and husk from rice as additional components of the mix that we used to 3D print Gaia. Then here there are some other things that I will unveil later on. Here in the middle there is the project, exactly as you saw in our business model, where here we develop the projects according to the 6 main domains that I listed before. And then at the left side of the picture, there is the heart of the company, heart beating of the company, because here is production, where these projects become products and solutions and can be shipped, can be delivered all around the world in order to generate revenues and to keep our business model spinning. Let's start with a quick overview of the 6 different areas and showing you some applications, real applications, and some related technology that we develop in order to accomplish these sectors and these goals. Regarding food, we worked in several directions because we worked in order to make a smarter cultivation with the WASP hortus. The WASP hortus is a project related to vertical cultivations where we developed, we designed, and we 3D printed this structure. It's a modular structure, the white that you can see here, using recycled plastic. Biocompostable plastic. It's PLA, and then we made some modules that you can combine according to the need in terms of vegetable that your family, your community need to produce, and then you can combine these modules in order to reach the number of plants that you are needing. And for instance, last year during summer, all the WASP team was taking advantage of the production that we were able to get thanks to our WASP hortus that is made of 6 of these towers. We were able to 3D print and to produce, to manufacture this WASP hortus, these huge modules, thanks to the Delta WASP 3MT. That is a huge 3D printer that can print a printing volume that is a cylinder with 1 meter of diameter by 1 meter of height. So it's really quite huge. It's designed to use both pellet form, so grains, plastic polymers in grains, or changing the head of the printer, you can use filament. So you see that you have more options for big prints like the modules that we have seen in the WASP hortus. We used pellet, of course, because they are huge, and if you are using the filament, you have to go much slower. Then again, regarding food, we also printed directly food. In this case, we were using chocolate. We were experimenting food deposition with some chocolate design for eggs and other sweet stuff. We also used additive manufacturing 3D printers for printing gluten-free cakes, biscuits, and we were exhibiting this project for gluten-free products during a very well-known exhibition a couple of years ago here in Italy for pastry and food, and it was very successful. Then we have also, beside the technology that allow us to print plastic polymers in filament or in pellet, as I said, we have also worked with another technology that is, let's say, a cold technology, because for some materials, fluid dense materials, you don't need to have a heated head. Because, for instance, to print ceramics, you are using a mixture that is fluid, it's fluid dense, and it's already printable. For plastic polymers, you have to melt the material. Doesn't matter if it's in a filament form or in pellet form. You are depositing it layer on layer, and as you deposit it, the material changes its state, and it becomes again solid. With fluid dense materials, you don't need to melt the material. You just need to print it with the material collapses. And then you can print several different fluid dense materials. For instance, also the gluten-free biscuits are, let's say, belonging to the fluid dense material application. House is probably the starting point of the WASP project and vision, because as I told you, the inspiration came from the Potter WASP, and the idea was exactly, what if we scaled up a 3D printer in order to 3D print houses, exactly as the Potter WASP does, using local sourced raw earth and natural materials. So the house topic, the house commitment is probably our, let's say, our most important and most challenging goal that we are facing. As I said, we started from the very beginning, testing, experimenting to print natural materials like raw earth with different kind of natural fibers to charge the mix. We developed 3 generations of printers for construction. The first one was, as I said, the Big Delta WASP, the 12-meter tall 3D printer that you saw in the green Shambhala. Then we moved to a second generation, where, as I said, we understood from the very first printer, the very first generation, that it was not efficient, because we had a lot of frame, and the printing volume was not completely exploited. So we were obliged to have a lot of frame, and we had the upper part of the printer, as the idea was to print the housing unit inside the printer. The top of the printing volume, the 50% of the printing volume was not used. So it was a waste in terms of materials, in terms of handling the printer, disassembling, shipping. So it was not efficient at all. So we understood that we had to rethink completely the design of the printer. And we developed a second generation that was, again, similar to the very first, but we cut half of the frame of the machine without compromising the printing volume, the existing printing volume of the biggest one, because we were able to make telescopic arms in order to preserve the printing volume of the reduced frame of the machine. So I would say that in terms of efficiency, it was better compared to the first generation, but we were not happy enough. So we said, no, we need to rethink again. We need to find another and more efficient solution. And we developed the Crane WASP that you are seeing here. The Crane WASP is our third generation in terms of 3D printers, WASP 3D printers for architecture and construction, for sustainable housing. This is Gaia, that is the very first house 3D printed using mud and rice waste. As I said, straw and husk from rice agriculture food chain, transforming waste into a resource to make an eco-sustainable with a very low impact, environmental impact housing. This behind is the big Delta WASP. Here, this area where Gaia is located is Shambhala, the green portion of the layout of our quarters. And this is the big Delta WASP, just to give you an idea of how big it is. Gaia, just to put some dates, Gaia was unveiled beginning of October 2018, 2 years ago exactly. This is, again, another project that we are completing right now. This is a mock-up of Tekla, always using the Crane WASP, but while during the construction of Gaia, we just used one Crane WASP, one module of the Crane WASP. For Tekla, as the shape, the design of the construction is much more complicated because it's a double dome like this. We used 2 WASP cranes working together in a collaborative way. So also in terms of design and in terms of complexity for the software in order to manage at the same time in a collaborative way 2 machines, the challenge coming from Tekla is much more higher, is much more complicated. Because in terms of shape, as you see here, the structure is really challenging the physics, because we did 2 domes that were reaching exactly the limits of the overhangs that a fluid dense material like mud can achieve, and also the challenge coming from the collaboration of 2 machines working together at the same time in a collaborative way. You see here the building site of Gaia with one module of the Crane WASP. The Crane WASP, it's a completely different structure compared to the big Delta WASP, the very first generation of our printers for construction, because here it's much more similar to a crane, to a standard crane, with some differences, of course. You have a column here, you have a arm here. The arm can rotate. The extrusion system can move horizontally on the arm, along the arm, and then the arm itself can move up and down. Then there are these three pillars, these three columns, additional columns to stabilize the wall structure, the wall printer. The building site is very simple because from here, number one is exactly where the material is sourced. So the material is locally sourced, is coming exactly from the building site. It's raw earth. Then the material has to be mixed with the natural fibers, as I said, and for Gaia and Tekla, the natural fibers are husk and straw from rice, from the rice waste. Then there is the feeding of the material to the extrusion system, and then there is the printing area where the extrusion system is depositing the material layer after layer. Where we got the raw earth became an aquaponic system, because if you see here, the area where we got the raw earth is behind Gaia. The roof is declined, so the rain is sliding down and is going into the pond here. And then we created this aquaponic system exactly from the hole where we got the raw material that was used to build Gaia. This is a render in order to understand what we envision with the Crane WASP, so the third generation of our 3D printers for architecture, because we can, it's a modular solution. So as for Tekla, we used 2 cranes, but we could use much more cranes in different configurations in order to expand the building site and the printing area. We envision that all what is needed to 3D print and to make a building site following this approach is a container in which you can put all the printers, all the hardware, software, and knowledge that you can ship, deliver all over the world where is needed. And we have called it the Maker Economy Starter Kit. I just want to give you a couple of figures because according to the World Bank report, Housing for All by 2030, they said that by 2030, 3 billion people will need new houses, requiring 300 million new housing units by then. So you understand that the Maker Economy Starter Kit and our solution could be one of the possible potential answers to address this problem, this huge problem. This is the Crane WASP. You can see here some different configurations where, for instance, this one is exactly what we use for Gaia. This at the right corner, down corner, is the configuration that we used for Tekla. for instance. And then you have a couple of other options, but you can play with different configuration according to the volume and to the area that is available and that you have to develop. This is again Tekla, a view of the inside of Tekla. As I said, from the beginning we worked and we experimented with plastic polymers on one side, using, as I already said, filament and or pellet, and fluid dense materials, what we have called liquid deposition modeling, LDM. And for these purposes, we have developed, beside the Crane WASP, that is the biggest printer that we have developed, a slightly smaller machine that is the Delta WASP 30 LDM, that is the sister of the other one that we used for the WASP Hortus. And this printer, this solution, can allow to print concrete or clay or raw earth, taking advantage of a continuous feeding system in order to allow the machine to get material and to print continuously. Let's move now into another domain that is very important and is mostly important nowadays, that is health. We created 4 years and a half ago the WASP MED multidisciplinary team in order to develop solutions for the medical sector for health applications. What we did was to create a multidisciplinary team, putting together different players, because we put together biomedical engineers, we put together medical doctors, we put together orthopedic technicians, then we put together producer of materials, of filaments, and ourselves. Why we did something like that, putting together different people with different skills, experiences, knowledge? Because we decided to focus our applications in the medical sector to very few simple final applications products, and they are corsets for scoliosis, for back pain problems, braces, sockets for prosthetic limbs, and prosthetic parts 3D printed remotely, custom made for skull. That's it. But we are not experts in these different sectors. So we said we need to have on board very experienced people who exactly know the needs of their patients, because they know what are the specs that a wearable device, an orthopedic wearable device, can meet. So we involved these experts, knowing perfectly their patients' needs. The material manufacturers, because according to the needs of the patients, the materials needed to be developed, to be fine-tuned in order to meet those specs. And then we were closing the loop because we had to be able to develop the right technology in order to print these materials exactly to make the final orthopedic wearable device that that specific patient needs. And then in the solution that we developed, that is called Digital Orthopedic Laboratory, we also provided a software in order to allow professionals who are orthopedic technicians, who are medical doctors, biomedical engineers, to model for orthopedic applications. And we developed a Blender plugin, a plugin for Blender 2.8, where the user can just take advantage of some specific tools, Blender tools, that are suitable for modeling a corset, for instance. They don't need to know everything about Blender. And then we also included in the Digital Orthopedic Laboratory education, because in order to digitalize an orthopedic laboratory, you need to implement, you need to change your production processes. And it means that you need to support, to guide these professionals in order to make this evolution. And this is exactly what we offer with the Digital Orthopedic Laboratory. You see some examples in terms of corsets. I can tell you that, for instance, 4 years ago, when we started the WASP Med team, the materials available at that time were not suitable for these specific applications. They were too brittle. They were not flexible enough. So we challenged, as I said, thanks to this multidisciplinary team, the manufacturers, the producer of materials, in order to develop brand new materials, able to suit the needs of this specific patient. And again, the Industrial X line is the machine, is the line of 3D printers from WASP that are included in the Digital Orthopedic Laboratory solution. This is a real example of a digital orthopedic laboratory that we have offered in Syria, in Damascus, because we got in touch with a medical doctor, a cardiologist from Syria who worked before retiring here in Italy, and he said, well, as I was very lucky in my professional life, I want to give back to my country, and I would like to help young people, kids with amputations due to bumps, to have their prosthetic limbs. And what we did was to offer a scholarship for a researcher, a biomedical researcher of the Damascus University, who went in Italy, spent a 2-month period with us in order to understand everything from the WASP Med team, in order to set up a digital orthopedic laboratory in Damascus. And we offered all the equipment, the education, everything, the whole package to the University of Damascus in order to do that. And this was the opening of the laboratory there. In order to work and to use also much more technical materials, we also developed brand new and more performant lines, like the Delta WASP 4070 Tech, that is capable to print also very technical polymers like PIC, for instance. Regarding energy, I have to speed a little my presentation because time is running. I could speak and tell you WASP story for days. We also work in terms of what we call the material life cycle. So recycling plastic polymers. For instance, last year we presented at the Maker Faire, the European edition in Rome, Regenera. That is a process where, starting from urban plastic waste that is called plasmics, we were able to crash these tanks, this plastic stuff, transforming into pellet, printing with our printers, the 3MT, the big one with pellet, and in this case, for the Maker Faire last year, we 3D printed some wind turbines in order to transform plastic waste into a valuable resource to make something that is useful, to produce energy in this case. Work, what is also the additive production, thanks to the additive manufacturing. Art and culture, that again, we were able to make several challenging projects thanks to our customers and partners, but mostly thanks to the versatility of our printers, of our technology, both in terms of materials that you can print and in printing volumes. This is an installation that was for COS, called Conifera, and it was last year during the Design Week in Milan, and it was an installation, a very challenging installation, where we used the PLA, that is a biocompostable plastic polymer coming from corn, and we developed these cones using 3 different types of PLA. One was neutral, one was white, and one was wooden. This is another installation that was made last November in Saudi Arabia. This was 2018. We contributed to develop at the Burning Man Festival the Galaxia Temple, designing and making the teardrops, these 30 huge drops, again made with biocompostable material. We also, in terms of art and culture, we also did this huge project that was the very first scenography for a theater piece that was completely 3D printed. Imagine that the scenography of this piece that was Fra Diavolo at Teatro dell'Opera in Rome, and then in Palermo, is 12 meter by 6 meter tall, and it's completely 3D printed, again using PLA, a biocompostable plastic polymer. As we said, we, from the very beginning, are very, very, very excited also to print clay, to print ceramic. And this is another example of an artist, Andrea Salvatori, who is not able to model with a computer. He's an artist. He can use his hands, but he's not a maker, he's not a scientist, he's not a computational design guru. But he said, well, I would like to interact with the technology. I would like to interact with my hands with the technology. And we did this this masterpiece that is called Ikebana Rock and Roll. and was unveiled again last year during the Design Week in Milan as well. I am going fast, but I want to spend a couple of words about the WASP Hub network, because we have developed, starting from, let's say, 3.5, 4 years ago, with the creation of some hubs, physical laboratories around the world, in specific cities, in specific countries. Here you see some of them, but again, it's a yellow picture. It's an obsolete picture already, because, yes, naming some of them, we have Madrid, Barcelona, Macerata, that is in Italy, Ravenna, Venezia, Salerno are in Italy as well, Beirut, Jersey City in the US, Mantova in Italy, Milan in Italy, Paris, Umeå is in Sweden, north of Sweden, Berlin, London are just some of them, where exactly each WASP hub is equipped with the same set of WASP 3D printers. And the work that we were able to do, for instance, here for Conifera and also in Saudi Arabia, we were able to do it because one of the WASP hub, London WASP hub, was asked to make the installations, but the single WASP hub was not able alone to have the production capacity that was allowing to meet the deadlines, the architect, the WASP hub. So the London WASP hub raised a red flag saying, "Hello, I am in troubles," and he launched a call for help in the WASP hub network, and 3 more WASP hubs joined, and the 4 of them were able to make the final installation, the final production of all the different modules that were needed for each of the installations. We did the same. We are doing the same for another installation that was expected to be this year during the Design Week in Milan, but unfortunately, due to the pandemic, the Design Week 2020 has been cancelled and will be unveiled next year. Again, thanks to the power, thanks to the capacity of the WASP hub network to increase the production capacity by a snapshot, because instead of 1 hub, 3 more hubs joined the call, and they were able to have by 4 the production capacity. This is our claim. So, dear customer, your dimension, your material, our solution. As I said, we have a huge variety, and we can offer a wide versatility in terms of materials that can be printed with our technology, because we can move from plastic polymers, filament and or pellet form to fluid dense materials like raw earth, like clay, like porcelain, like grass, like terraglia, like different fluid dense materials, concrete as well, even if we don't like it because it's not sustainable, and also with a huge variety of different printing volumes, because we can go from smaller machines, this is our smallest version, our smallest machine, to the crane WASP for architecture. And these are exactly the aspects that the market, that customers and prospects can take advantage of. So they can really have a huge variety in terms of materials and printing volumes. This is an overview of Shambhala. At the right side, there is the building in the middle, that is project, and imagine mirroring another one at the left, again, the similar to this one. You see Gaia, the big delta wasp, the wasp hortus, the aquaponic system here. The rain is coming down into the little lake, then with some solar panels, the water is watering the wasp hortus, and then the water is coming back again into the lake. Here there are fishes, and it's an aquaponic system. Okay, thank you very much. I think that it's a question and answer.
Hi. Hello?
Hello?
Hi. Yes, ciao Davide. Thank you for that presentation. But I believe we'll still be, we still have one speaker after you. Is it Massimo?
No.
No. Okay. All right.
No, Massimo was not able to attend.
Okay. Yes. Thank you for clarifying that for me. Okay. Yeah. So personally, I have a lot of questions I would like to ask because I actually just came back from the Netherlands and I lived in Eindhoven, and so I know it's like a city that has a lot of 3D printed houses and buildings, and so I find it fascinating to see the actual. Of course, it's not the same, but the kind of technology that goes into building these structures. But I'm going to go through the chat, and I see so far, I think maybe people still have a lot of the hamsters rolling in their wheels right now. They're trying to figure out what kind of questions to ask you. So maybe I can fire off my own questions if that's okay.
Yeah, let's start.
Yeah, okay.
Yeah.
I'm curious about the kind of, so like I mentioned, like the architecture right now is kind of fascinating for me. And right now, a lot of, from what I'm familiar of, like the kind of beautiful structures you've made, they're still, are they on more one-off pieces? Is it sort of like more of a speculative kind of presentation? Or have you gone into like commercial housing pursuits already or ventures?
Well, I try to explain a little the evolution of the project for 3D printing in construction, because we did Gaia, as I showed. Then we developed Tekla, that is an even more challenging solution in terms of design and in terms of technology that we used. Now we are starting as soon as possible, because we are in winter now, we are in Italy. We are starting a building site for a private client in Tuscany. So he is willing, he is going to buy a 3D printed house, 3D printed with our Crane WASP technology. Then we also have requests coming from municipalities, coming from general contractors, real estate developers, to develop projects. What we try to do right now, as we are using let's say, non-conventional material, because raw earth is not there is no history behind raw earth that is 3D printed, and the behaviors of the same material that could be used in form of Adobe compared to a 3D printed material, the same material, behaviors are different. So what now we are trying to do is to work together with the client, with the architects from scratch, because the process can be split in three sub activities. One is the design process, where you have to define the shape, and the shape, according to additive manufacturing, has some constraints. So you can take advantage of some aspects due to the additive manufacturing technology, but you have also some constraints. So the first is the design process. The second phase is the mix design, because again, you have to fine-tune the recipe of the local sourced raw earth in order to make it printable. And we saw that, according to our experience, in the same building site, when you go deeper, digging, in order to get the raw earth, the composition of the soil is changing. It's not the same in the same area, in the same place. If you go deeper, you can find differences in terms of composition. So the mixed design is very important, because otherwise you can't print it. It's not printable. And then the final process is the printing, the building, the construction. So we try to work together with the clients, with the customer from the beginning, covering all the three sub-processes.
Okay, yeah, so I'm quite excited how that client in Tuscany would have, how he would experience like an actual 3D printed house. Because you always see these, but you never really hear from the people living in them. And it's so, I'm sure he'll have like a really interesting experience. We have a question here on, okay, I also thought about this because I was looking at your map of all the WASP hubs. So it's very Northern European right now. And so we have here from Sir Edmund Mamboyo. He asks, does WASP have an office here in the Philippines? Or do you plan to have, I don't recall seeing any Asian WASP hubs yet so far. So
no, exactly. Correct. It's true. No, we don't have at the moment any office or distributor in the Philippines. We are present in a lot of countries, so we are selling everywhere in the world. We are selling in North America, we are selling in Australia and New Zealand, we are selling in India, in the Middle East, we are selling in Europe, of course, and we are strengthening our presence where we already are working. In some countries where we are already present, we are trying to strengthen our presence even more, and we are also expanding our presence, entering in countries, in regions where we are not present yet. I see on the chat, I see here a question from Roy Bayonas. Hello, Davide. Are your technologies open source? Maybe I can answer it.
Mm-hmm. Go
okay.
ahead.
Yes, correct. As I said at the beginning, we started as makers. So we started exactly being part of the maker community. And the first step of WASP was serving makers. Our approach is exactly an open source approach. In fact, I mentioned that for the WASP med team and for the digital orthopedic laboratory, we developed a plugin of Blender 2.8. Blender is an open source software, for instance. Yes, we are open source.
All right. Okay. So it's good to know that you're open source and that if anyone is interested to sort of work on that aspect of your company, what is the best way for them to contact you or look through your projects?
You can, as you prefer. We are open source and open-minded. So it's we receive almost daily requests from students, from researchers, from companies looking for some solutions. And this is another aspect that is peculiar to WASP, because as I said, versatility in terms of materials, versatility in terms of printing volumes, but also we are able to find, together with potential customers or existing customers, together the solution that is really what they need for their problems, to answer their needs. I make an example. I met a gentleman 5 years ago at TCT in Birmingham from a huge company. They work in the steel sector, so it's a very tough environment. They were looking for solutions to allow them to make the molds where they pour inside the steel to be more flexible, because they were obliged to keep some shapes and they were not able to answer their customers' requests of changing the shape of the molds, and they are using refractory materials. So we started to think together, and he was leading a small team in order to introduce additive manufacturing technology in their processes 5 years ago. And at the end, we started with a small printer for clay. We trained one of the guy of his team in order to be able to 3D model, in order to be able to generate and optimize the G-code, the tool path of the machine, and to print fluidized materials. Then, from the small one, printing clay, printing ceramics, they started to experiment together with us, and then together we developed a solution that we have installed in Poland, because the company is based in the UK. They have another factory in Poland and they have a subsidiary in the US. And starting from small, we were able to work together in order to develop a process for their needs. And then now we are working in order to allow them to recycle a waste that they don't know how to use, that could be suitable for something else, thanks to our technology. So we are working together in order to co-develop and making some tailor-made solutions for them.
Okay, super. So maybe we have time.
So we are reachable. Everyone can contact us. Absolutely.
So, okay. Yeah, please find their website, send them an email. We can already see that David is super open to your questions. So you should.
Yeah.
So maybe someone is interested in like collaborating with you here in the Philippines to make some storm-proof architecture, because God knows how many storms we're having right now in the Philippines. Yeah.
We are, for instance, we are working. We have a well-established cooperation and collaboration with the IAC, the Institute of Advanced Architecture of Catalonia from Barcelona. For instance, we are now having a girl from Peru. She's making her internship at WASP because she is attending a master in design by data in Paris. So she's from Peru. She's studying in Paris, and now she's spending 4 months at WASP in order to prepare her thesis project.
Yeah, that's a really great architecture program that they have there. Okay, so we have another question. Did you receive from a representative in DTI, Mr. Ariel Negasca, did you receive any government support or any type of intervention?
No, because unfortunately, in Italy, let's say, Italy and Europe, it's not easy at all. I can tell you that we tried to submit some projects related to 3D printing, sustainable architecture, with some of those projects and grants from the European Union. One of them was called Horizon 2020 for small, medium enterprises. We tried several times to submit different projects, but we met the threshold, but we were not funded. So we didn't get money for that. But who cares? As I said, our business model is a bottom-up business model. We try to answer the basic human needs, as I described. We develop advanced technologies, we sell them, and we finance the company and the project. So even if we are not able to get money from the European Union, we go ahead, we move forward, we step by step. Probably what we saw is that when we started in 2012, we were the very first to think or to envision to 3D print houses. We wanted to do it using natural, locally sourced materials, not concrete, for instance. We were able to make a lot of experience firsthand because we are really working with mud. We get our hands dirty because we really work very hard in terms of computational design, but also on the field. And then we saw that a lot of other companies were appearing 3D printing in architecture. And as they were based in other countries, in other places where probably the funds are reachable, or maybe the venture capitalist approach is more developed than in Italy, they were able to grow much faster than us. But for us, it's important to have a physiological growth. So we are acting with the resources that we can get from what we do. So in a nutshell, no, we didn't get any support from the European Union or from the Italian government.
Okay, but it's still great to hear that you've managed to do well without government support. For some context, of course, we have several listeners here who are from either DTI or DOST or AMCEN. They're all like government institutions. So I think they're very curious to know how you're able to do this all privately.
Well, maybe we are not. So if we can get some supports, they are more than welcome. So far we did everything with our energy, but for the future, why not? Because we want to speed up what we are doing.
Of course, you can get as much help as you need when it's offered. We have another question here. It sort of touched on what I mentioned earlier about all these storms that we're having in the Philippines. Someone is asking, Belle Daida is asking, are the printed houses, I assume she's talking about the ones you presented, like Gaia, etc. Can they sustain earthquakes and typhoons?
It's a good question. We are, as I said, managing all the process from the beginning. We are also looking for collaboration and partnership with universities, research centers, because we need to meet all the different requirements that in each country are needed in terms of structural calculations, in terms of earthquake, typhoons, etc. So it's a work in progress because there are different rules in different countries.
All right. Okay. So I think it's really on a case-to-case basis on who you work with, and of course, research. Next, we have.
What's its environmental impact? Where would you get large amount of mud, clay, and straws for large demand of client?
Forcing.
I would say, I would say that the impact. It's very, very low because you can use what you can find locally, and it's not a matter of huge amount. It's you can find raw earth. And regarding natural materials, it's not needed to use, for instance, rice. We use the rice here in Italy because, as I said, Italy is the biggest producer of rice in Europe. So the waste coming from the rice food chain is huge. So we used this natural material because it's available here. In other places, in other countries, you can use, for instance, the banana trees cut, or maybe you can use the coconuts waste. In Sardinia, always here in Italy, you can use the waste of the sheep's wool, because there are a lot of sheep, and the waste of wool that is not used for the fashion sector is perfect to be used for mixing with raw earth.
Right. We have, I think we have someone asking about if you could do a satellite office here in the Philippines. I think that's kind of been covered in a previous question about your presence in this country. There's another question again about your choice of material. Like, is it necessary? Like, what about plastic waste, PET bottles? Just to let everyone know, we actually have another set of speakers who will be covering 3D printing with recycled plastics as the material. So you should also watch that webinar in the future. But Davide, what is your input on that?
Well, as I said, we try to cover also the material life cycle. So we try to put in place, and we presented it, and we are promoting it, a process where, for instance, if you have urban waste, plastic waste, as I mentioned, the plasmics that we used for Regenera project, you can take advantage of it to make new objects that are useful for other purposes. Or we are also very committed in order to offer our partners, our customers, solutions where they can, for instance, take advantage of failed prints, of prints that were not were not successful, and they can, with a specific device, can crash the objects, then create grains, so pellet. And thanks to our technology, because we started to make available in the market the pellet printing system with our Delta WASP 3MT in 2016. So we started from 4 years ago to provide a solution to print pellet form, because the pellet form can be helpful to recycle materials, and also can be very, very efficient when you print with big printing volumes. Because if you consider the price point of the filament, same plastic polymer, the price of the filament is 6-7 times higher than the same plastic polymer in pellet, because you are skipping a process that from pellet is going to generate the filament. So we pay a lot of attention in order to allow makers, our customers, whoever, to take advantage also of the waste that they can generate. So to recycle plastic, but not for construction, not for architecture purposes, of course.
All right. But it's good to hear like this aspect of circularity still being considered in your whole process. So
yes, as I mentioned, this year with the WASP Hub network, we were supposed to make a very challenging and important representative installation during the Design Week in Milan 2020. But as it has been cancelled and postponed to next year, you will see next year that we will present, hopefully, this huge project that is the client is Dassault System, with again Arthur Mamumani architect is the architect who has been involved in order to design this installation, and as Arthur Mamumani is the WASP Hub London. Again, he launched the call for help into the WASP Hub network, and 2 more WASP Hubs joined the call, and we have 3 WASP Hubs, London, Milan, and Venice, working all the 3 together for this installation for next year. And this installation, commissioned by Dassault System, will be around the material life cycle. So be tuned, because next year it will be very, very exciting.
Super exciting, and let's hope that COVID does not affect another design week for everyone, because it's really changed everybody's schedule. Okay, I actually just want to clarify. So these WASP hubs, were they already like maker spaces beforehand and they applied to be hubs, or did they apply to be hubs right away and then built themselves?
Good question.
Yeah.
Good question. Very good question, because as I said at the beginning, when I presented the picture of the team, of the WASP team, first of all, the right people on board, the right people on the bus. So we, let's say, selected, it's not really the right word, but let's say we selected the WASP hubs according first to the people. So apparently the WASP hub network is a mess, because you have architects, you have computational design gurus, you have different skills together, but each member of the WASP hub network, each player, can offer different knowledge, different networks that are creating a huge value in the WASP hub network wall itself. So basically, it's I can tell you that, for instance, London is an architect firm, but is also managing it's called FabPub, Fabrication Publique, that is a FabPub, a Fab Lab, basically. FabPub, because he's from Paris, Arthur Mamoumani is from Paris, so used the name Fabrication Publique instead of Fabrication Laboratory, instead of Fab Lab. But it is wearing two hats. One is an architecture firm, and the other one is a Fab Lab. In Barcelona, they are architects, very skilled in terms of computation design. It's a blend. It's a blend of different skills, experiences, and networks.
It's very multidisciplinary. So it's not just like it has to be just very engineering-related makers. It has to have a level of creativity.
First of all, the right people on the bus. Second, they of course need to be on the same page of WASP vision. So they need to be on board, to be part of the whole vision. So all of them are motivated to save the world.
Exactly, just like that.
And then last, the location. But the location is really the last aspect that is important for us. Most important, people, coherence, with commitment, and the same frequency on which we are, and then the place, the location.
Like right amount of same level of crazy. Basically. Crazy enough to save the world through manufacturing. Okay, so we have a few more questions, and a lot of them really are going into the details of the printed houses. So like questions like cost efficiency, would you say that they're more cost efficient than conventional housing?
Well, I would say that as we are at the beginning of the process, it's like when you manufacture a prototype. So at the moment, the costs are still let's say higher than the final costs. Of course, it's like when you make one piece, and then afterwards you enter into production. So you can take advantage of a scale economy. So at the moment it's still a prototyping phase. So the costs are not the final ones. We are still working. We understood that there are some phases during the process that could be digitalized even more. But just to give you an insight that is very important, one of the most efficient aspects of 3D printing in architecture is that you can go from the computer to the building site. So you can transfer the information from your computer to the building site straight. So you are completely skipping the blueprint phase that you need to follow with the traditional construction process. That is a phase in which you can have a lot of mistakes, a lot of reworks, and it's a very time-consuming and costly phase. This, with the 3D printing in architecture and construction, is completely skipped. Do you completely skip it?
Yeah, I imagine even like just assessing how much material you would use, you don't really need to put not as much thought anymore, because you're able to gauge already like how much concrete you would need, etc., etc.
Yeah.
Okay. So the last couple of questions we have here are more on a very local context. So like questions about like being in terms of approval for building permits. I'm not sure how much information Davide would have on that. Maybe other people in the chat could chime in if they're interested on answering Ms. Journalita's questions. Or like, have you run into any government issues when trying to build these buildings with any kind of government?
Not so far, because as I said, we try to work from the beginning with architects, engineers. So also locally, we try to fulfill all the different rules and standards that locally are needed. So the private client, we are working, and already we can start the building site, and we can start working. On another application that is related to the municipality of a city here in Italy, the architect is already working with the municipality in order to transform the let's say the construction, the building plan of the city in order to allow to make it, because we are going to make 3 or 4 GAIAs for a campus of a university.
Okay, so I think that's it for I have one last question because we've covered a lot of the architecture. I'm actually also interested in the food because this is quite funny. I have an Italian designer friend, and he's worked heavily with 3D printing for food. And of course, he decides to reinvent pasta. And so like redesigning the shapes and all that. And when he was testing it out with me, I was really fascinated with how you could change the composition of the food itself, like in terms of percentages. And so I'm curious how you think, like in terms of 3D printing, how it could change like personalizing nutrition for the masses once they like come into closer contact with 3D printing and food.
Yeah, another interesting and I would say huge question.
Yeah,
because
your experience anyway. Like
it's really huge. As I said, we did some experiments. We did some experience in terms of food printing, and as you saw, we started at the beginning printing and depositing food. So we used chocolate, for instance, and we printed chocolate things, shapes. Then we printed gluten-free stuff. We printed pasta as well, because we were asked by a world leading Italian company to yeah,
of course.
True. But we were asked a few years ago, but they asked for exclusivity, and we were not able to find an agreement with them. Then we moved from depositing food material into the, let's say, the smart cultivation. So we moved backwards instead of moving close to the dish, close to the table. We moved to the field, and we worked in order to create, as I said, the WASP hortus in order to work in terms of smart cultivation. Yeah, okay. But I think that the food sector is really sparkling. It's very exciting and excited by the additive manufacturing in terms of a lot of different applications. So I think it's a very promising sector, and there is a lot to do.
Yeah.
For sure.
Who knows? Someone might try to get a WASP 3D printer here and start 3D printing Filipino food. Yeah. So I think that is it for all our questions. And so thank you, Davide, for gracing us with your presence this afternoon. I'm sure people still have so many questions, but of course, they're always welcome to contact you through, what is your website?
It's, let me see, it's 3D WASP, 3 number, dwasp.com.
Okay, so if you have any more questions, if you would like to see the kind of work that they've been developing, very, very exciting, just check out 3dwasp.com and find their other contact details there. On November 6th, we will also be having another webinar featuring another exciting speaker. And for the rest of November, we would also have, so for November 6th, just to give everyone a heads up, we will be having a speaker we have both the speakers from Malaysia and the Netherlands. So from Malaysia, we've got Lim Mun Chun, who will be speaking on data preparation, the key essentials for 3D printing. And from the Netherlands, we've got Pedro Lima, who will be talking about desktop filament making, breaking new ground in the development, production, and recycling of 3D printing materials. So that already touches on a question someone had earlier. And so until then, thank you everyone for coming. It was a really exciting conversation that we had here with Davide. Ciao, Davide. And ciao, everyone. Thank you for joining us.
Thank you very much. Ciao. Ciao. And have a nice day.
You too.
Ciao.
Thank you. Thanks, everyone.